Now that we've had the 6 trigonometric functions defined for us, it's time to look at some applications of those functions. So what I want to do today is look at 2 word problems, and demonstrate the thought processes that you might go through in solving these problems. First of all, suppose that a 10-meter ladder is leaning against a building, such that the angle of elevation from the ground to the building is 62 degrees. Find the distance of the foot of the ladder from the wall. Also find the distance from the ground to the top of the ladder. Now, of course, the first thing you might want to do in solving a word problem is try to understand what they're asking, try to understand the context of the word problem. And this one's fairly straightforward, because we can all visualize a ladder leaning against a building. What might cause us a moment's pause is this phrase, angle of elevation. The angle of elevation refers to the angle that's made with a horizontal line. So in this case, it would be the angle that the ladder makes with the building. Now, to help us to understand the problem, almost always with these right-angle trig problems, it's a good idea to draw a picture. So let's do that. We've got the building here. We've got a ladder. Now, once we draw that, we label the given parts. We know that the hypotenuse is 10 meters. That's the length of the ladder. We also know that the angle of elevation is 62 degrees. Now, once you label your knowns, once you take care of what you're given, you assign variables to the unknowns, what you're looking for. So I'm going to assign x and y. Y being the distance from the ground to the ladder, and x being the distance from the building to the ladder. Now, after you assign these values, you begin to look for relationships between what's given and what you're trying to find. Now, in this case, you're given 62 degrees and 10 meters, and you're looking for example, y, the distance from the ground to the top of the ladder. So you're looking for a way to relate the 62 degrees and the hypotenuse to the side opposite the 62 degrees. Well, clearly that's suited for our trig function sine. In fact, what we're going to do is say, well, the sine of 62 degrees is equal to the opposite side, y, over the hypotenuse, 10 meters. Now we have an equation that we can solve, because this is an equation with numbers and one unknown, and we know how to handle that. All we need to do is multiply both sides by 10 meters and use our calculator to find the sine of 62, and we find the answer to be 8.829 meters. So the distance from the ground to the ladder is 8.29 meters, or 8.829 meters. Now, to find x, the adjacent side, the side from the building to the foot of the ladder, well, that's of course cosine. We take cosine 62, the adjacent side over the hypotenuse, and solving in a similar fashion as before, we find that that distance is 4.695 meters. And that's what they ask us to find. So we find the building from the ground to the top of the ladder is 8.829 meters. To the ladder from the building from the bottom to the foot of the ladder is 4.695 meters. Now, on to another problem. Suppose that atop a 100-meter vertical cliff, a ship is spotted at an angle of depression of 12 degrees. How far is the ship from the base of the cliff? That's the first question. Also, find the distance from the top of the cliff to the ship. Okay, so let's see if we can draw this picture. We've got the cliff, we've got the boat, and obviously we need to draw a line from the top of the cliff to the boat. Now that is one of the questions that we were asked. What is the distance from the top of the cliff to the boat? So that's what we want to find. We want to find the length of that line. And you can see here that a right triangle is formed. Now we also know that the cliff is 100 meters high. And at this point I'm going to go ahead and label the hypotenuse. That's one of the things we want to find. And also I'll label this distance from the cliff to the boat. That's another unknown that we want to find. Now, for the other given part, I waited to do this because I want to talk about this for just a second. Notice we were told that this is the angle of depression. Now, the tendency might be to try to put that angle of depression inside the triangle. You know, you see the 12 degrees, the tendency might be to put the 12 degrees inside the triangle. But remember, the angle of depression has to do with the angle that's made with the horizontal. So in fact, the angle of depression goes here. But we can figure out this unknown side, because obviously the cliff and the horizontal line form a 90-degree angle, 12 of which is taken up by the angle of depression. So we can find the remaining angle by taking 90 minus 12 and get 78. So the angle inside the triangle is 78 degrees. Now we're at the point where we look for a relationship between what we know and what we're trying to find out. Now, first of all, you notice that the side opposite the 78 degrees is x, and the side adjacent to it is 100. So right away that tells us that we might want to use tangent 78 degrees because it is opposite over adjacent. So that gives us a relationship we can use right away. Solving for x as before, we find that x, the distance from the cliff to the ship, is 470.463 meters. Now at this point you could use the Pythagorean theorem to find c, but since we're studying right angle trig, let's go ahead and use our trig functions. We need a way to relate 78, 100, and c. Well, what comes to mind is we've got an adjacent side and a hypotenuse, so perhaps cosine. Cosine 78 degrees equals the hypotenuse on the bottom and the 100 meters up top. Now this time we've got our variable on the bottom, but we can still solve that with a little bit of basic algebra by cross multiplying. And we find that c equals 100 meters over cosine 78. And that is 480.973 meters. Those are the two things we wanted to find. The distance from the top of the cliff to the ship, 480.973 meters. The distance from the cliff to the ship, 470.463 meters.